so let's run through these. They're quite short to do. I just need to borrow a pen and I don't think I like your calculator for some reason. Do I like your calculator? Oh, it feels weird, yeah. I'll borrow this and the pen, please. I'll probably take your pen. Okay, thank you. Alright, so let's have a look at these questions. Right, number 1. What? It doesn't matter to me, it'll write, so I'm fine. Am I recording? Yes. Number 1. An ideal transformer or power station is used to step up the voltage from 25,000 to 400,000 volts. The number of turns in the secondary, or determine the number of turns in the secondary if the primary has 800. So it's that, and then it's 800 turns, and then it's that, and we don't know how many turns. So it's 25,000 over 400,000 equals 800 over x.
You can cancel them.
Yeah. So, large number, yeah? X is 12800. Did you get that? Okay, now it says determine the current if there's 5 megawatts of power in the input. Okay, so the power equals IB, and the I equals P over B, and the power is 5 mega, and it's the current in the input, which has a voltage of 25 kilo. So that is, it's 0.2 times 10 to the 3. Is that right? 200?
Yes.
Yeah. So the current is 200 amps. Okay. So I mean that's 4 out of 4 marks. 4% of the exam, section A, 2 marks. Not so bad. Can I go to the next one yet? So number 2, an ideal step-down transformer is used, has an output of 24 volts, has an input of 125 volts. The primary we don't know, and the secondary is 216. So we would like, stop it. Look, if you want to punch me in the face, I can look away while you do that. Yeah? Right. And we want the x here. So we have x over 216 equals 125 over 24. So you have x equals 1125? Yeah. And next now, determine the current in the primary when the secondary has a resistor of 8. So what they're saying here, the power going in must equal the power going out. What's that? Oh, which part? Oh, I'm sorry, not the secondary. I did the primary. So I just need to change which number. This is 4 times 10 to the, change this one here, isn't it? Oops, sorry, this one here. The voltage should be 4 times 10 to the 5. Yeah. 4 times 10 to the 5. So what's that? 1.5 12.5? Okay, 12.5. So when I said 200 and everybody said, yep, that's it, go ahead, continue. Did you really get 200 also? You made the exact same mistake I made. No, so you said nothing because you didn't want to hurt my feelings, was it? Yeah, right. Okay, so number 2 now. Power in equals power out. What's the formula for power? IV in equals IV out. Out, in. Now, we don't have the I, do we? So we should maybe use Ohm's law or something. We want to replace it. But wait, what are we looking for?
The current.
We are looking for the current.
We have resistance and voltage.
Well, we have resistance and voltage, yeah. So we know both of the voltages, so let's put them in at least. What's the voltage going in?
Can we just use the Ohm's law?
Well, we will in a second, yeah. Can we use it directly without this? Do we have enough? Can we use V equals I or? Oh, we can. Yeah, we can do this. We can just use V equals I or. I equals V over or. What's the V? It is 24. And what's the or? It is 8. Yes? So 24 divided by 8, 3, isn't it? Yeah. So 3 amps. Yes? Did you get that too?
Yeah.
But it's going to ask for a primary.
Yeah. So this is just
This is the second.
Alright, so we're only halfway finished then. We got the secondary and they want the primary.
Yeah.
So we use Ohm's law again. V equals I or. I equals... Oh, hang on. No. No, hang on. I know what to do. Just be quiet, please. I'm going to use what I was a minute ago. Power in equals power out. So V in, I in, equals V out, I out. Now, what's the voltage going in? 125. What's the current going in? That's what we want, isn't it?
Yeah.
What's the voltage going out?
24.
24. And what's the current going out? 3. We just worked it. So, let's see. 24 times 3 divided by 125. 0.576. What's wrong, Daniel? Look, I don't know. I'm hungry. I want to get my lunch, okay? Did you get the same answer? If you did it a short, if you did it shorter way, good for you. Yeah. 0.576 amps. Okay, number 3 now. The voltage in is 250. The voltage out is 20. The primary has 850 turns. What's the secondary? So we have X over 850 equals 20 over 250. 68. It's correct. Yeah.
And the thing is also the way around. Oh, okay.
Yeah. Both are swapped. Now, what is the current in the secondary? If the current in the secondary is 6.4, what's the power? Okay, so power equals IV, which equals 6.4 times 20, which is 128. Okay. Yes, it's great, isn't it? Right. 4 now. I feel like something stupid just happened. Yeah. Hamish.
No, I mean, can we just keep question number 4 because it's similar to like the previous one.
Hamish, I would have been finished by now if you didn't interrupt me. Yes. Alright. Ideal step-up transformer increases the voltage from 25 kilovolts to 275 kilovolts. The primary is 500 and the current is 1 kiloamp. What is the number of turns here and what is the current here? Right, so firstly, N over 500 equals 275 kilo over 25 kilo. So the kilos cancel. 275 divided by 25 times 500. 5,500? Yes, no, thank you. It's not necessary. The satisfaction of you learning is enough for me. 5,500. Now the current. What will I use for current? V equals IR? V equals...
Power.
Hold on. We don't have... I think... No, I don't have the OR, so I can't. Yeah. Power in equals power out, which is IV in equals IV out. So the I going in is 1 kilo. The voltage going in is 25 kilo. The current going out is what we want, and the voltage going out is 275 kilo. So the kilo on the left and the right cancel. So we have 25 divided by 275 times 1,000. 90.91? Yes. So the I equals 90.90. Thomas, I wouldn't have said that was very similar. Was it? Oh, whatever. 6 now. We'll just go 6 part 2. Now, what's wrong?
No,
That's great. Thank you.
Yeah, that's right.
Yeah,
6 part 2. The power plant produces 120 megawatts with a voltage of 33 kilovolts. Before being transmitted, the voltage is... Oh, sorry, that 33 is the beginning. 33 kilovolts, but it's increased later to 144 kilovolts. Now it's going to be more than 120 megawatts because the process is 90% efficient. Anyway, here there's 5,000 on the primary. We want the number on the secondary. So we can have N over 5,000 equals 144 over 33. Hang on, N over 5,000. It's a really large number, isn't it? Yeah. So then the N here is equal to 2376000. So the N is, let me see, 1, 2, 3, 4, 5, 6, 23.76 megaturns times 10 to the 6.
Yes.
No.
218. Yes, 21.82 times 10.
Did I type it in wrong?
Yeah.
Yes.
Probably you type 30 instead of 50.
Oh yeah, it is. It's not this big. I had like 2 billion turns. N equals 21818. Yes, okay. Now, if the transformer is 90% efficient, what is the current passed from the output? So we want the current on the output if it's 90% efficient. So what I'll do is I have the voltage.
You can find the power in.
Yeah, I can get the current. I don't actually care that it's 90% efficient, do I?
Yeah.
Determine the current passed from the output. Does that mean to say passed to the output?
No, from. They want the current out. So first you can find the power out, and then you can find the current out. It doesn't matter.
Now, hold on, this is important. Do we need to use the 90%?
Yes.
Yeah. And they're looking for the current over here, is it?
Yes. No, they're looking for out.
Input to the distribution.
Output to the distribution.
Output of the transformer to the distribution system. Well, that's here.
So this is in.
Input of the distribution.
Yes.
Stupid English. Right.
Then you don't have to use the power.
Alright, so
You can use N1 divided by 2 equals I2
you could use this one, yeah. Well, that's the same thing as the power here, but I'm not happy.
With the power keep it. Yeah.
I'm not happy about the English in this question.
Let's leave it for the next time when all of us will French.
Yeah. Hang on, just give me 10 to 20 seconds to read it again. A power station has a generator that produces that of AC with a voltage that, before being transmitted along a distribution system, the voltage is increased to 144. If the transformer is 90% efficient, right, so I see what the problem is here. I drew my 120 on the right. It's not. It's on the left here. The 120 is made and then it's transformed. Now this doesn't change my answer here because I didn't need to use it. So the 90% efficient actually means 10% is lost. So I can very quickly get the number on the other side is 108. So now I have power equals IV, I equals power over V, which is 108 times 10 to the 6 over 144 times 10 to the 3. 75? 108 divided by 144 times 10 to the power of 3. 750 is the I. Okay. 750 and right, 7. 2,000 turns on the, look, come on. I want my lunch too, so if we just finish these two, then we're going. 2,000 turns in the primary, 240 volts. Secondary is 100 turns. Voltage we don't know. An RMS current of 1 amp is taken from the secondary, so there's 1 amp here. What is the current taken on the primary? So first I'm going to get the voltage. I don't know if I need it, but I feel like I might need it, so I'm going to call the voltage here X volts. So we have X over 240 equals 2,000 over 100, which is 20 times 4,800, is it? 4,800?
Yeah.
Volts. Here.
So for
No, so I did something stupid.
100 was 2,000.
X over 240 equals 100 over 2,000. I had it upside down.
Yeah.
So then X would equal 12, is it? Okay. But we don't want this, we want the current. So I can go with Ohm's law? No, I can go with power. Yeah. So the power in is I times 240 equals the power out, which is 1 times 12. So the I is just 12 over 240. 0.05? Yeah. 0.05 amps. Okay, and what's next? What is the electrical resistance? Well that's just Ohm's law. V equals I or I equals V over or, which equals 12 over 12 ohms. Right, finally, 8. An ideal transformer has 2,400 turns in the primary. It's connected to 220 volts. The secondary has 110 turns. And again, it's don't know how many volts. There's a 1 amp here. We don't know how many amps here. And what is the current taken on the primary? Hey, that's exactly the same as 7, isn't it?
Yeah.
Alright, so we can do it really quick. I'll just wait until you unpack now. So you're just delaying yourself. I'm just going to wait. You're delaying yourself.
He's looking for his glasses.
His hipster glasses.
Yeah. See everything by 50
Yeah, sorry, number 8 would make no sense without your hipster glasses on, right? Okay, so what do we do first? The voltage. X over 220 is 110 over 2400. 110 divided by 2400 times 220, that's 10.08?
Yeah.
Okay. And then what do we want next? Again, the resistance. So we can say IV equals IV. Just like this?
Yeah.
So then the I is 10.08 divided by 220. So the I is 0. I can sense the movement. Like I can feel it here. 0.0458 amps. Get out of here.